Hi, so I'm gonna do my best to show you how to derive Einstein's special relativity equations. They stem from there are two postulates that the whole thing is based on. Number one, that the speed of light is constant in all reference frames. And the second thing it's founded on is that the laws of physics apply in all reference frames. So these are, upon these two postulates, the speed of light and special relativity comes from. And it comes from Einstein theorized if you had a platform, and then up here there's a mirror, and if you were to send a laser beam up, it would bounce off and come back down. Now, this is kind of akin to throwing a ball up in the air. So if you're standing still, if I'm in the reference frame of you, you throw a ball up in the air, it comes back down in your reference frame. But what if we move this thing? So what if we took this platform and we moved it with some velocity? Well, we would see, if we were standing outside the reference frame of this moving thing, we would see the light beam, the laser beam traveling this distance. Now, the speed of light is the same in all reference frames, which says that if there's somebody riding the bus, they would see the light go up and go down, but us standing outside the bus see the light going on this diagonal, and it's supposed to take the same time. Well, it can't, because the postulate of light being constant. So he derives his equation from this, and what he does, it's founded on really the Pythagorean theorem. So where he started was by saying that let's just call the time it takes for the light pulse to go up and go down, we'll call that t naught over here in this case, proper time. Over here we're going to call this one t, however much time it takes to go over there. So we have t naught and t. We'll define this distance right here as the letter d, and we'll define this velocity like we said before. This is going at some velocity to the right at velocity v. So what we're going to do is we're going to try to relate t naught to t through the velocity v and the speed of light, because this is traveling at the speed of light here, and so is this pulse right there. So what we're going to do is we're going to use the Pythagorean theorem, and the Pythagorean theorem comes kind of right here. The Pythagorean theorem says a squared plus b squared equals c squared. Like this, where you have a is this leg, b is this leg, and then c is the hypotenuse. But what I'm going to do, it's really interesting, I'm going to relate, these are all distances, but what I'm going to do is I'm going to relate them all. I'm going to list all the distances through velocity and time, because this is an equation you learned early on in physics that says velocity is equal to distance over time. So if I move the time over, I get velocity times time equals distance. So what I'm going to do is define all three of these distances here as a velocity times a time. So this distance right here actually comes from over here, the velocity, which is the speed of light, times the time, t naught. But it's actually half of that. So because this goes up and then comes back down, it's half of it. So this is 1/2 the speed of light times t naught. This one right there. Now I'll define this side right here in terms of velocity and time. So this, remember, the time takes to go up and back, so this is also 1/2 v times t, regular t, because it's half of the, because if it were traveling the whole distance, that would be velocity times time, but it's only going half the distance. Now then this side up here, we're going to call it, well, it's, again, the velocity that it's going is the speed of light, and then the time is using is letter t. So this is 1/2 c times t. All these are half again because the full length would be all the way up and all the way down, the full length here, and then the full length over and back. So now what we've got is we can use the Pythagorean theorem where a squared 1/2 v times t, the bottom leg, plus a squared, so it's this whole thing squared, plus 1/2 c times t naught squared, and that equals c squared, the hypotenuse, which is 1/2 c t squared. Now everything that you do from here on out is basically algebra. Like the physics is kind of done, it's just set up here, but this is all I'm going to do now is just a little bit of fancy